All right, so I was actually asked to talk a little bit more about cylindrical shells and actually discuss this particular problem. We've done it previously in class, but I think it's a good problem to help us illustrate what it means to do shells. So what I'm going to do is I'm actually going to draw this graph here right now. And what we're going to see is, so here's y equals 9, okay, and here's 0, and we've got the line y equals x, and then we've got the line y equals 9 minus x, okay? And what we're looking at here is, and we want to go with the x-axis, so it's this line, this region right in here, okay? And we are going to go about the x-axis, okay? Using cylindrical shells. Now, here's the thing about cylindrical shells, okay? The idea with a cylindrical shell is that you're developing cylinders, okay? So we have these cylinders, and the height of the cylinders, okay, and the radius of the cylinders is all dependent upon the axis that you're selecting. So in this case, or well, if we are rotating around the y-axis, then the height is vertical and the radius is horizontal, okay? So basically what we're saying here is that the radius is going to be perpendicular to the axis of rotation, okay? And the height is going to be parallel. So if you think about it this way, it kind of makes sense. So here's our axis of rotation. Say, for example, here's our y-axis of rotation. And you want to think that we're going to create cylinders by rotating around that axis of rotation. So that's basically what we're going to do right there. Well, if you look at this, here, if this is the y-axis, okay, then our height is parallel to that axis. And our radius, r, is going to end up being perpendicular. So if we think about this in relation to the x-axis, okay, let's say we did the x-axis here, and now we imagine we're rotating a cylinder around there. In this case, my radius is going to be vertical, and my height is going to be horizontal, okay? So for the x-axis, for rotating around the x-axis, the height is horizontal, right? Again, parallel to the axis, and the radius is vertical. So that's kind of how we're thinking about this. So now what I'm going to do is I'm going to say, okay, well, let's look at this particular instance up here, the one that we've got in this case in our problem. We're now going to be rotating around this axis, around the x-axis, and so consequently my height is going to be parallel to that x-axis. Well, if we think about that, what that means is that each one of these shells, its height is going to be this line. I'll make this line, we'll highlight it in yellow. We're going to take the yellow line, which is y equals 9 minus x, minus, okay, and we'll use the pink line minus the pink line. And the reason why that's the case is because the yellow line is furthest away from the y-axis, and the pink line is the one that's the furthest away from the x-axis. Or excuse me, is the closest to the y-axis. So furthest minus the closest, right? The biggest minus the smallest, like we've been doing, that's actually going to end up giving us the value for our height, right? Okay, so like if I imagine here, I've got these cylinders, and I'll use blue. This is the first height, the one that's going to go directly along the x-axis. And then we're just going to layer height upon height upon height, right, as we have a changing radius. So as my radius changes, my height changes, okay? Well, what's our radius? Well, our radius in this case is going to be that y-axis, okay? So our radius is going to be the y-axis. So for example, here's my radius. You imagine the cylinder going around the x-axis, so my radius is going to be some value for y. And when, say, for example, I'm at this point, then here's my height, okay? So it's going to actually relate to some y value, right? Since we're going around the x-axis, our radius is going to be some value of y because it's on the y-axis. Okay, it's going to end up being some value for y on the y-axis. And my height is going to be the difference between 9 minus x and x in terms of y. Okay, so in terms of y. All right, so in this case, we just noticed that as I move up from 0 down here to whatever this point is, right here, which ends up being 4.5, okay, to 4.5, my radius gets bigger, but my heights all get smaller and smaller and smaller until finally when we hit 4.5, we have no height at all. That's the idea, okay? So that's kind of how we're imagining the values that go into each one of these cylinders, okay? So just to review, the radius is going to be the one that's perpendicular to the axis of rotation, okay? And the height is going to be parallel to the axis of rotation whenever we do cylindrical shells. And that's really important to understand and really important to remember. So now, given that that's the case, we actually have to think that since we're going around the x-axis, our heights have to be in terms of y, our bounds are going to need to be in terms of y. So we're going to need to actually do that changing up, okay, in order to, in fact, find the values for the cylinders. So we'll start with noticing I have y equals x is one of my functions. I have y equals 9 minus x, okay? So I'm going to find that x will equal 9 minus x, okay? So 2x equals 9, so x is going to equal 9 halves. So that's a value for x, by the way. But since y equals x, okay, then we also know that y is going to have to equal 9 halves as well. So that's going to be the bounds for my shells. Okay, so it's going to go. Our function is going to go from 0 to 4.5, like I said before, 0 to 9 over 2. Okay. Now, so there's our bounds. We have y is going to be greater than or equal to 0, less than or equal to 9 over 2. Okay. And now, in addition to that, we're going to actually have to go in and figure out what the functions are that we're going to be working with. So on the one hand, I have y equals x. And so if I wrote that in terms of y's, that would also be x equals y, right? Pretty straightforward. And then I have y equals 9 minus x. So doing a little bit of algebra here, I get y minus 9 equals negative x. Excuse me, y minus 9 equals negative x, which would then give me that 9 minus y is equal to x. And so there's our function of x. Okay, now I just go in and I use my volume for the shells. And that's why we've been talking about the radius and the height, because what we're looking at here is the surface area for shells. The surface area for shells, and how we find that surface area for each shell is going to be, right, so surface area for shells, that equals 2 pi r times h. We already said that our radius is going to be y's in this term, in these terms. So we're now going to find that the surface area, or not the surface area, but my volume is going to equal 2 pi times y times, and this will be 9 minus y dy. Okay, because this is the top function and here's the bottom function. So this ends up equaling the integral of 2 pi y times 9 minus 2y dy. And that, in fact, ends up being our function. All right, and just to add in our bounds, we have to be out of 0 to 9 over 2, 0 to 9 over 2, and there we are. Okay, so big thing to remember with shells, okay? Big thing to remember when we were working with cylindrical shells is that whatever axis that we're rotating around, the height is going to be parallel to that axis, and the radius is going to be perpendicular to that axis, okay? So basically, that's how we're going to have to think about things. I'm rotating in this case with respect to the x-axis, so my radiuses are all going to be y's, and my heights are going to be in terms of y as well. And so we want to think in terms of the top one, the one that's furthest from the y-axis, minus the one that's closest to the y-axis, and that ends up giving me my height. Okay? Plug it into our function, and we end up with the volume based upon cylindrical shells. So this completes the lesson.